It's April 1820. A lecture hall in Copenhagen. The afternoon light filters through tall windows, illuminating dust particles that drift lazily through the air. Hans Christian Oersted stands before a small group of students, his hands steady as he prepares a demonstration. He's a physicist and chemist, a man obsessed with finding hidden connections in nature. Today, he's showing them something about electricity, about the way current flows through a wire, but his mind is elsewhere. For years, he suspected something that no one else believes, that electricity and magnetism, two forces that seem completely separate, might somehow be related. He connects a battery to a wire, current begins to flow, and then, almost by accident, he glances at a compass sitting nearby on the table. The needle moves, not toward the north, but perpendicular to the wire. It swings, as if pulled by an invisible hand. Oersted freezes. He disconnects the wire. The needle returns to pointing north. He reconnects it. The needle swings again. In this quiet moment, in an unremarkable room on an unremarkable afternoon, everything changes, because that moving needle has just revealed a secret about reality that will reshape the world. For centuries, humanity had known about two mysterious forces: magnetism, the strange pull between lodestones and iron, the way compass needles always pointed north, and electricity, that spark you could generate by rubbing amber, that flash of lightning in a storm, that current Alessandro Volta had learned to create with his battery just 20 years earlier. Both forces were invisible, both seemed almost magical, but they existed in separate worlds. Magnets attracted iron, electricity flowed through wires and created sparks. They had nothing to do with each other, or so everyone thought. But Oersted wasn't convinced. He was a romantic scientist, influenced by the philosophy of nature philosophy, a movement that believed all forces in nature were connected, that beneath the surface diversity there was unity. He'd spent years wondering if there was a hidden relationship between electricity and magnetism. If you ran current through a wire, could it somehow create a magnetic effect? Most scientists dismissed the idea. There was no evidence, no reason to believe it. But Oersted couldn't let it go. The question haunted him. What if they were missing something obvious? What if these two forces were two faces of the same phenomenon? Before 1820, science saw electricity and magnetism as entirely separate forces. Magnetism came from iron and lodestones, those mysterious rocks that pulled metal and guided compasses north. Scientists could describe it and use it, but not truly explain it. Electricity, on the other hand, was movement and spark, the shock from static, the current from Volta's early batteries, the power that split water and lit glowing wires, but it didn't attract iron or move compass needles. It behaved nothing like magnetism. To most scientists, this division made sense. The world had different forces, and not everything had to be connected. But Hans Christian Oersted wasn't satisfied. He believed nature was unified, that no force stood completely alone. And so, he kept searching for a link no one else thought existed. Oersted's breakthrough didn't come from luck alone. He'd been chasing this idea for years, reading, testing, failing, but never letting go of the belief that electricity and magnetism were connected. In April 1820, while giving a lecture, he set up a simple demonstration, a battery connected to a thin platinum wire, to show how current produces heat. Nearby sat a compass, perhaps just part of another experiment. When Oersted turned on the current, something unexpected happened. The compass needle moved. Not much, but enough. It shifted from north and pointed sideways, perpendicular to the wire. He stopped the current. The needle returned, started it again. It moved, reversed the flow. The needle swung the other way. This was no accident. The electric current was creating a magnetic effect. Electricity and magnetism weren't separate after all. They were two sides of the same force. The movement of that needle may have seemed small, but its meaning was enormous. For the first time, humanity had proof that electricity could produce magnetism. Current flowing through a wire created a magnetic field around it. Invisible circles of influence, swirling instead of pointing, following what would later be known as the right-hand rule. Oersted spent months repeating his tests with different wires and currents. In July 1820, he published a short paper in Latin, just 4 pages long, announcing that electricity and magnetism were linked. Those few pages changed the course of science. The news spread fast. Scientists across Europe rushed to repeat Oersted's experiment. In France, André-Marie Ampère quickly developed a mathematical theory showing that electric currents could attract or repel one another, that electricity itself could act like a magnet. In England, Michael Faraday became obsessed. If electricity could create magnetism, could magnetism create electricity? 11 years later, in 1831, he proved it could. Moving a magnet near a wire generated current. The connection went both ways. From that insight came the entire modern world. Telegraphs, electric motors, generators, transformers, power grids. Every device that uses or produces electricity traces back to that moment when a compass needle moved beside a wire. Look around your room. Nearly everything you see depends on Oersted's discovery. The lights above you, your phone, computer, appliances, speakers, MRI machines, all work because of the unity between electricity and magnetism. But his legacy isn't just technological, it's philosophical. Oersted showed that nature's forces aren't isolated, they're deeply connected. His discovery inspired James Clerk Maxwell to unite electricity, magnetism, and light into one elegant theory, and later inspired Einstein's search for a grand unifying framework of physics. Oersted wasn't chasing fame or invention, he was following curiosity, a belief in hidden connections others overlooked, and that belief reshaped the world. There's something profound about that small movement of a compass needle. It revealed a truth that had always been there, unseen. Electricity and magnetism had always been one. Oersted's discovery reminds us that the universe is more connected than it seems, that beneath the surface of what looks separate, deeper patterns wait to be found. It took patience, curiosity, and the courage to notice what others ignored, a tiny deflection that changed everything. In the end, Oersted's story isn't just about science, it's about what it means to be human, to wonder, to question, and to look at the familiar with new eyes. That's how one man's curiosity turned a moving compass needle into the foundation of the modern world.